Okay, so you combined it and you did, let's make this actually look like a 4. Log base 6 x plus 4 times x plus 3 equals 1. Okay, then what'd you do?
And then I factored it, and then I turned out to be log 6, and then in parentheses, x squared plus 7x plus 12.
Equals 1. How do people feel about that? Are we okay with that? Is there a question yet? You got to ask questions. Put it in the chat if you don't want to speak up. Okay, we're good with that so far. Okay, and let's ask. So Mia, what did you guys do? How would you continue from here, or were you stuck, or what would you do here?
From there, we turned it into exponential form.
Great.
So we got x squared plus 7x plus 12 equals 6 to the power of 1. So just 6.
Mm-hmm.
And then after we did that, we subtracted 6 on both sides. And we got x squared plus 7x plus 6 equals 0.
Very good. So let me just stop right there just to make it clear. When we're solving a quadratic, we want to get everything on one side and set it equal to 0. So that's the only way to really solve a quadratic. Everybody okay with that? Okay. Okay, Mia, keep going then.
Okay, then after that, we were trying to do the product and sum of, so product was 6 and then sum was 7, and we like cut off there, and we had to come back to the main room before we could find the two numbers.
Okay, okay. Well, I'm going to look at this and I'm going to say that the two numbers are 6 and 1. I think that works. Does that work? Yeah, and you would have found that if you did. Mia, what? You look so surprised.
Yeah, okay, so we had 6 and 1, but we were like 6 and -1, and they were like, that doesn't work. So if we would have, yeah. Mm-hmm.
Yeah, it's got to be positive. 6 and -1 would mean this had the -6, but it's not. It's positive 6. Okay, so 6 and 1. All right, good. And you know, if you're having trouble factoring, what do you do when you're having trouble factoring? If it's too weird to factor or it doesn't look like it factors, what do you do? Somebody speak up. What do you do when you can't factor it?
The quadratic formula.
Thank you very much. Quadratic formula always works, never fails. Quadratic formula never fails. Okay. All right. So we got to here so far. So then, well, then looking at that, I'm saying that looks like my answer should be then -6 and -1. Those should be my answers. Is that right? I'm seeing heads go no. Okay, Juji, can you tell me why those answers aren't right?
I can't because I messed up. So
where did you mess up?
I messed up like right in the beginning, and I honestly don't even know what I did wrong. I think I just like was confused. But I think I kind of guessed, but I didn't like, yeah, I'm confused as to what I even messed up on, but it's just very different from this. So yeah, I'm just trying to figure it out, but it makes sense like now that I'm watching it.
Okay, so you're okay with where we're at?
Yeah, I'm okay with where we're at,
okay.
But I don't know like what would make this wrong.
Okay, well, you're going to find out in just a minute what would make this wrong. Jordan, do you know why this is why this might not be right?
No, I don't know why.
You don't know why? Okay, fine. We'll just keep going until we find somebody who does here. Sydney, do you know why this might not be right?
No, I do not.
We followed all the steps though, right? It looks right, doesn't it? It looks right to me, right? Okay. We'll go one more here and then we'll take a volunteer. All right, so Crystal, why might this not be right?
So
because the domain would be -3 to infinity. So the answer that works is -1.
Right. Okay. So how did you find the domain?
So we did x plus 4 is greater than 0 and x plus 3 is greater than 0. And then we got x is greater than -4 and x is greater than -3. And when we put that on the number line, the where it meets both requirements is at -3 to positive infinity. So that's how we got the domain.
Yeah. Okay. So we got +5. So if this is our our blue one right there, that goes from -4 to infinity. And if this is our red one right here, that goes from -3 to infinity. Yeah, and this space right here between -3 and -4, that is only crossing one line. It doesn't cross both lines. So our domain is -3 to infinity, and that means -6 is out of luck. Only -1 is good. Sydney, make sense? Did you guys try work on the domain, Sydney? No, you didn't.
We didn't get to that part.
Oh, okay. All right. Jordan, make sense to you? Yeah. Okay. So are we done? Are we done with this problem? No, we're not done with this problem. Why not? Now, Mia, now you can give your answer.
We have to graph.
Graph it. Come on, let's graph this guy, make sure it works. +4 + 6. So let's take a look. Jimi Hendrix. Okay, so we got to do another one here. So I go functions log base 4. Is that right? Is it log base 4? Log base 6x plus 4. Oh, I could have left it then. Log base 6. Come on. Stop. One more time. Log base. There we go. Log base 6 x plus 4 plus log base 6 x plus, what was it? 3? No, what? X plus 3? Okay. X plus 3. So that's a flat logarithm curve. Wow. And you can see, starting over here at -3, that's where it starts. And equals, what was it, 6? No, what does it equal?
1.
1. Oh, y equals 1. Y equals 1. So let's make it back to where we are. And I'm looking where it crosses, and that's not our answer, is it?
Wait, Mr. Jenkins, for the first, for the purple line, is it
Plus.
plus sign? Yeah.
Thank you very much. Yeah, that was not looking too good to me. Yeah, okay, now it works. Pretty good? All right, excellent. Let's see what we got coming up. All right, so do practice problems. I mean, that is the only way you're gonna get this, So, and I don't think you need to do a lot of practice problems. I think you do, a handful of practice problems. You're gonna like. It's gonna make sense. Okay, so let me think here. Yeah, let's introduce you to this. We'll introduce you to this here. Okay, so we can use our properties of logarithms to solve logarithmic equations, but we can also use our properties of logarithms to solve exponential equations. An exponential equation is an equation where the variable is an exponent. Okay, that's an exponential equation where the variable is an exponent. So there's a couple things we need to know. If I have a to the u power, and that equals a to the v power, well then u is equal to v. Or if I put it in numbers, if I had 2 to the x equals 2 to the third, can you, I mean, it's pretty clear here that x is equal to 3, right? So same base, I can, if I have same base, I can just set the exponents equal to each other. Works just fine. But now with a problem like this, I don't have the same base. In fact, I only have one exponent in this equation. So the key to solving exponential equations is property 3. It's the property log m to the r is equal to r times log m. This is the key to using logarithms to solve exponential equations, because this lets us get our exponent down into the base. So if I'm solving 3 to the x equals 7, okay, well, 3 to the x equals 7. I'm going to take a logarithm of both sides. And, you know, honestly, it doesn't matter what kind of logarithm you do. Log base 3, log base 8, log base 10, ln, it doesn't make any difference. Any logarithm. So then what that turns this into is x times log 3 equals log 7. All right, I want to make sure everybody's with me here. Everybody follow what I just did there? Using the property logarithms, get that variable that's trapped as an exponent, like Rapunzel. Rapunzel, let down your hair, you know, and then lets down her hair, and then the exponent is now part of the base. Y'all know Rapunzel, right? Everyone knows Rapunzel. Okay, right. So now log 3, it's just a number. It's a weird looking number, but it's just a number. So I'm going to divide both sides by log 3. And I get x is equal to log 7 divided by log 3. Now, just to be clear, this is not log 7 over 3, okay? This is not using the properties of logarithms here. This is just one number divided by another number. Okay, so I don't want you to make that mistake. So I get my calculator, and I'm going to go log 7 divided by log 3, and I hit enter, and I go x is approximately equal to 1.77. And you want to see something else kind of neat? Watch this. I'm not going to use log base 10. I'm going to use ln. So I'm going to go ln, that's log base e, ln 7 divided by ln 3. Same number. Or I can go math alpha math log base 2 of 7 divided by math alpha math log base 2 of 3. Same number. Yeah. So it doesn't really matter. It's just one logarithm divided by another logarithm. And this is my approximate answer. Then, as you all know, I go to graph it. 3 to the x equals 7. So I'm going to go back to my graphing. Whoa, I didn't want that. How'd that happen? There we go. I want to graph this. First, I'm going to graph 3 to the x. That's a nice exponential graph. And it equals 7. So y equals 7. Oh, that's way up here at the top. I got to scroll down here. And I find out that happens at 1.77. Answer is correct. Super duper. Okay, that is enough for the day. We will, I just kind of wanted to introduce you to that, and then we'll continue with some more problems on Monday. Yes, Mia, please.
I just have a question about the first step of why you were able to add a log to 3x and then also to 7.
Yeah, great question. So let me ask you a question. If I had like, well, I'll use the same thing. If I had 3 to the x equals 7, would it be okay with you if I took a square root of both sides? Is that acceptable?
Yes.
And what if I have 3 to the x equals 7, but I decide, no, I would just like to multiply both sides by 8. Can I do that?
Yes.
Yeah, so 3 to the x equals 7. I can take a log of both sides. It's just another operation that I'm doing. I'm just doing an operation, and as long as I do it on one side, I can do it on the other side.
Okay, thank you.
That work? Yeah. So and it's super handy because it's that operation that lets me get my variable down into the base. Pretty cool. Okay, so I'm glad you asked that question. And that's it. It's community time. So I got 2 of my junior steering committee people right here. You guys got a honor code committee well planned. I saw that. It looks excellent. So we'll see you over there in a couple minutes. Yeah. Okay, everybody else, you're welcome to come to the honor code committee meeting. Got a great meeting planned. So it's going to be in my office. So we'll see you later.
Thank you.
Thank you.
Welcome.
Thank you.
You're welcome.